Welcome back to Calculus with Mr. Walton. Today we're going to talk about the trapezoidal rule. And from our textbook, that's section 55A. Let's look at the trapezoidal rule because sometimes we need to approximate the area under a curve. So to do so, we're going to use the following formula. Instead of taking the integral from a to b of f of x d of x, we're going to use capital T, meaning the trapezoidal rule is equal to h over 2 times the quantity y sub 0 plus 2 times y sub 1 plus 2 times y sub 2 plus etc., etc., 2 times y to the sub n minus 1 plus y sub n. Realize this is where a to b is our interval, and it's partitioned into equal subintervals where h is equal to b minus a over n. We can also calculate this if we have our rectangular approximation methods with the left and right summed and divided by 2. Why do we need to know this? What if we do not know f of x? We use the trapezoidal rule. When we are given just data points. Now, when we have a function that is concave down, what we need to remember is that we will have an underestimation versus when we have a function that is concave up, we will have an overestimation. Let's look at an example. Given the integral from negative 2 to 2 of the function 4 minus x squared dx, where n is equal to 4, let's use the trapezoidal rule to approximate the integral. First thing we're going to do is we're going to find that a and b. We're going to find h using b minus a over n. Therefore, starting at negative 2, here are our intervals. We plug in 0 when we plug in, then we get 3, then we get 4, then we get 3, then we get 0. These are our lovely y values, and these are our x values. Therefore, we have y sub 0, y sub 1, y sub 2, y sub 3, y sub 4. Please remember that in between we have 2 times y sub 1, 2 times y sub n minus 1 in between. So anything that's in between, we're going to multiply the values by 2. So when we find the summation to this, we're going to get 1/2 of 20, which is equal to 10. Now, let's make sure we look at percent error as well, because we should be able to calculate this. Given that our actual integral is from negative 2 to 2 of the quantity or the function 4 minus x squared dx, we can say that that is 4x minus x cubed over 3 from negative 2 to 2. And we're going to get 8 minus 8 thirds, negative 8 plus 8 thirds, so that we get 32 thirds, or 10 and 2/3, whichever you prefer. If that's the case, let's please remember that percent error is equal to the absolute value of actual minus estimated over actual times 100%. So our actual, 32 thirds, minus our estimated, which is 10, over our actual, which is 32 thirds, times 100%, is going to give us 1/16 times 100%, or 6.25%. One more. Use the given chart and the integral to approximate the area using the trapezoidal rule. So now we are already given our chart. We're given from 0 to 3, and we have n equals 12. So we're going to use every single value we have. First, a is equal to 0, b is equal to 3, so h is equal to b minus a over n, which means h is equal to 1/4. So for the trapezoidal rule, we are going to have 1/4 over 2 times 1 plus 2 times 0.25 plus 2 times 2.75 plus 3. And we would put all of the values into our calculator to find that we're going to end up with 1/8 times negative 257.1, which gives us a final value of t sub 12 equal to negative 32.1375. That's 5.5a.